Good afternoon and welcome to our talk on bringing augmented reality to ancient London traditions. Basically, how did we manage to create a technology world first with AR float for the Lord Mayor's show? Stick with us for the next 45 minutes or so and we'll be able to tell you exactly that.
And don't forget, if you have any questions, please put them into the chat mechanism.
So I'm Danielle Green, liveryman at the Worshipful Company of Information Technologists.
And I'm Stuart Mitchell, liveryman at the Worshipful Company of Information Technologists.
And you're probably asking what exactly the Worshipful Company of Information Technologists are, which is something that we will get to very, very shortly. We're also going to tell you about the livery companies and the City of London, the Lord Mayor's show itself, how we produced the augmented reality technology, got a V-float on the road, and what happened when it was showtime. And as Stuart says, don't forget to put if you have any questions, don't forget to put them in the comments below and we will answer them as soon as we can. So here we are. As I've said, I'm Danielle Green, liveryman with the Worshipful Company of Information Technologists. It is a membership organisation, which is one of the 111 livery companies in the City of London. As a membership organisation, basically we do a lot of pro bono projects and technology work alongside our day jobs, whilst also indulging in some of the interesting traditions of the City of London. So what are livery companies? Well, they were established quite a long time ago in the City of London, originally to protect and regulate the various trades carried out within the city itself. So effectively, ancient guilds or trade unions. There are a fair number of them and they've been going for a while. For example, the first in the order of precedence, the Mercers, in the top left-hand corner here, these are all the arms, was actually established in 1394. The most recent company, the 111th, was the Nurses, given the order of precedence of 111. And we'll leave it to the more those of you to decide exactly why they decided on that number of precedence.
So a lot of the traditional industries supported by the older livery companies have since disappeared. But in those cases, the modern livery companies like the fan makers, for example, now support the aerospace industry because of the links with fans and aero engines. And that's just one example where the core feature of philanthropy, which is common to all livery companies, continues, thus the industry that they support changes.
So you'll have noticed that there's a real difference between the ancient livery companies and the more modern ones. And funnily enough, that's the two groups that there are. So here we have actually the modern livery companies. And I'm sure you won't be surprised to hear that our livery company, the Information Technologists, fits into this latter group. There's no hard and fast definition of exactly what makes a livery company modern, but it is generally accepted. The first was the Master Mariners, who achieved livery status in 1932. And so any company, livery companies that have achieved their livery status after that date are in the modern group. This is going to be a bit of an important fact, and you'll see later on for the way that we created our AR float. Because the modern livery companies themselves have got their own walking float, which is organised by the firefighters in there at number 103. But I'm sure actually you'd like to know really what a float is. So what's a float? What's the Lord Mayor's show? And what has this got to do with augmented reality? So the Lord Mayor's show actually dates back to 1215, so the beginning of the 13th century, when a desperate King John, I'm sure you've all heard of him, granted that the City of London could actually appoint its own Lord Mayor. So this might have been around the time of a small document that you may have heard of called the Magna Carta. So, however, King John did decree that each newly elected mayor should come upriver to Westminster and swear loyalty to the crown. So in 1215, the mayors have been making that journey, which was originally by river, and therefore were joined by many of their supporters also floating up the river in their own aquatic vehicles, hence the name of float. Eventually, the Lord Mayor's Show made it onto dry land, and now every November, the newly elected Lord Mayor, because the Lord Mayor of London is elected on an annual basis, process around the City of London with a whole load of very colourful, exciting floats and much pomp and ceremony. This is actually what it looks like now with the very famous Golden Coach. And we're just this year, on the 9th of November, the 696th Lord Mayor, Alderman Alistair King, will be making his way up to Mansion House as part of the whole procession. There is a procession route which is followed every year, and the whole Lord Mayor's Show is broadcast internationally, with the BBC covering quite a lot of it. It's really well worth going, and we'd absolutely encourage you, if you're around on the 9th of November, to go and see the Lord Mayor's Show. So how did we end up deciding to put an augmented reality float into the Lord Mayor's Show? In some ways, the story started in 2015 when WCIT had their own float a whole 9 years ago, and had been thinking it was time to do it again. However, conversations had been started, and then there may have been a little bit of wine involved, but the idea was mooted that if we were technologists, we should use technology to actually have a float in the Lord Mayor's Show, and it should be an AR one. But it was decided that maybe we should do it that year. I just would like to say that this was actually in May or June that we decided we should do this to try and create a float for the November. And I think the adage is that if you don't know how difficult something is, then you're going to end up doing it. And maybe the whole thing that naivete was the mother of innovation.
So the technical bits, how do we bring the technology together? So I'm going to cover some basic concepts of augmented reality and QR codes, and go over some details of both of these technologies, which were critical to this particular project. So AR, augmented reality, is a technology that overlays digital information and virtual objects onto the real world, enhancing the user's view of the environment. In some use cases, this can also include interacting with virtual objects. By using devices such as smartphones, tablets, or glasses, AR applications can superimpose images and sounds onto the physical world in real time. So this is in counterpoint or opposed to VR or virtual reality, where the entire field of view is replaced with imagery, and that can be based on a real or imaginary environment. An important concept in AR is the idea of anchoring. It's a crucial process that allows virtual objects to be placed and appear to remain stable in the real world. When an AR application is launched, it uses the device's camera and sensors to detect or recognize specific points or surfaces in the environment, known as anchors. So these anchors can be anything from flat surfaces like tables and floors to more complex objects like images, 3D models, or in our case, QR codes. Once an anchor is identified, the AR software uses it as a reference point to position and orient virtual objects accurately. This ensures that the virtual elements appear to stay fixed in place even as the user moves around. In addition to using visual processes to detect the surfaces to be used as anchors, it's also possible to use the gyroscopic hardware built into modern smartphones to determine the initial point of view and orientation in a scene. And then by using the gyroscopes, you can track the motion of the smartphone in order that it keeps the rendering correct, such that the virtual objects appear in a fixed location. A well-known AR application is the game Pokemon Go, as shown on the bottom left image, where players use their smartphones to find and capture the Pokemon characters, which are rendered as though they're sitting on roads, pavements, tables, or flat surface. So the picture there shows a Marill if you know your Pokemon, sitting on the road. If you look a bit closely, you can also see an artificial shadow rendered as part of it onto the road to make it look like it's more realistic. Another technology important to this project was the use of QR codes. So a bit more detail about those. So QR code is short for quick response code, was actually invented in 1994 by a Japanese automotive company. So the QR code's design, it features a square grid pattern with the 3 bigger squares in the corners indicating which way up it's going. And it allows it to be quickly read from any orientation. Unlike barcodes with the vertical lines, it can store significantly more information, including website URLs, plain text, and other data. There are several features in the design of a QR code, like the small black squares making up the grid itself are known as modules, and the number of modules needed to encode the particular data you're trying to encode is dependent on the length of that data. So there are actually different versions of QR codes, numbered, not surprisingly, from version 1 upwards to number 40. So version 1 is the smallest in terms of the grid size, measuring only 21 by 21 of the little black modules across. Version 40, the largest, has 177 of the tiny black squares per side for a total over 31,000 modules. So the choice of which version of QR code to use depends on the amount of data you're encoding. The more data you have, the bigger the QR code has to be. QR codes also have error correction levels built in as well. So there's levels of redundancy in the pattern, which means you can code it in a way such that part of the code can be obscured and the device rendering it or scanning it can still extract the information. Again, the higher the level of protection or redundancy, the more modules you need to use. And the last feature I want to mention, which is sometimes overlooked, is there's a big white border. This is actually a design of the QR code feature itself. It's called a guard area. And again, it's important so that when a camera or smartphone is visually processing it, it can find the QR code itself and differentiate it from the background. So how do we use these technologies together with the Lord Mayor Show? So as mentioned earlier, the Lord Mayor Show is a mixture of vehicles and people walking through the City of London. Only a limited number of livery companies have real vehicles in the show each year, and the other companies have members from the companies walking together in various groupings. So as the WCIT is a model livery company, in the 2023 show, we had 3 WCIT members walking along with people from the other companies, the other modern companies. So traditionally, each company has a placard with its name and armorial crest on. So using that as a starting point, we came up with the idea of having extra placards to be carried with QR codes on them so that these could be scanned by the spectators as they pass by. And that would then trigger the sequence of launching the software. So in the discussions about what could be included, seen in the augmented reality view, that went through many iterations with lots of discussion. Initially, we were starting to thinking about you having literally a virtual vehicle, like a lorry. The problem with that is that would require a clear area or clear space gap in the procession to fit in a virtual vehicle. And again, without people walking in and out of it, which would make it look bad. Another issue with this idea is the line of sight. Only spectators in the front of the viewing areas will be able to see it. People behind them would be obscured and wouldn't be able to get line of sight. So that was discounted fairly early on. So then the ideas turned to thinking about having a float, which was literally above the procession, literally floating up above. And that was agreed upon. And floating above the procession avoided lots of these issues. We made the change and basically based the design on a balloon because that's a bit more realistic floating. Also, don't forget, historically, real balloons have been used by livery companies in the show, including, for example, the Paviors with their very large floating pig. So having a balloon, a virtual balloon, would be a suitable choice. So fairly early on in the process, it was clear we would need to do some prototyping to demonstrate whether this was feasible at all. As Danielle mentioned, we didn't know what we were up to at the start, and he said if we'd realised what the challenges were, maybe we wouldn't have started. But we started anyway. So up to this point, it had been theoretical discussions about how these things would be put together, and it seemed to be theoretically possible, but we hadn't actually tried it. So, by using a combination of a couple of tools, there's a thing called Blender, the Blender modeling package, and a web service called MyWebAR, it was actually relatively quick and easy to put together some prototypes as the ideas and design has progressed. So this is a screen on the slide at the moment from Blender showing a couple of views. One is the right-hand side is the wireframe view of a balloon model. And on the left is the artwork I was using to inspire me for the shape of the balloon and also for the design of the outside. So basically I took the 3D model and the artwork from the balloon, created a texture map, added in the crest from the modern livery companies to produce a texture map wrapped around the whole balloon. So this is a snapshot from the WebAR tool, web service I was using. And so this shows the combination of 3D elements. So you've got the balloon element, you've got the text logo, and then you've actually got the barcode. And inside this tool, you can move the elements around relative to each other. So what I was doing here was using, so this software this example is normally used for QR codes on business cards where something sits above the business card. In this case, the QR code was flat and the object was actually layered so that it would appear directly above it. So rather than having the QR code flat on the card, it's being upright, so the whole model would be located above the QR code. So another technical issue we discussed fairly early on was the software needed on people's phones to actually see the augmented reality scene. An early design decision we made was that we wanted the user to be able to see the scene without requiring an app to be downloaded and installed. As people are aware, when you go to load an app, it can take time, and that would then be a barrier in terms of speed and complexity for the users. So we decided we needed to use what's called WebAR technology. So this is where browser technology, browsers built into the phone as part of a standard feature, which run WebGL, WebXR and JavaScript, was all that was needed to be able to render the augmented reality scene. So, for the initial tests, I printed out a very large QR code and hung it on my washing line, as one does. This was to simulate the QR code being mounted on a placard and then held vertically. So these are some screenshots from my phone where I was doing these tests. As you can see in the left-hand two shots there, an early version of the augmented reality object was actually a literal lorry floating in the sky. One issue there, it's interesting you can see, for example here, modern smartphones are usually used in a portrait orientation, and it would be possible to pan the phone backwards and forwards, but you wouldn't be able to see the whole object in the one screen. So again, that was felt not a good idea. That's another reason for moving to the concept of a balloon, which is more easily rendered in a portrait orientation. So here on the three right-hand images, you can see the evolution between the different designs and different iterations. There were still a number of technical challenges with this approach even, so including the size of the QR codes. So they needed to be as physically large as possible to increase the chance that spectators' phones could actually resolve them. So codes which are far away are practically the same as being small, so as in Father Ted. A second challenge was the fact that they were in motion. So that because they're being carried and not held in one place, this was why the guard or area, the border around the outside, was actually very important, because again, if it's moving in front of a complicated background, the camera might struggle to actually analyze it. So having the proper guard area helps that. And then the third challenge was that we wanted the individual modules, the small black and white squares that make up the code, to be as large as possible. in order to increase the chance of being scannable at distance. So this really drove us to use what I was referring to earlier, the version 1 code, the simplest version of the QR code with the fewest black and white blobs. So that meant we had to have a very short URL target as the encoded string. So to get around the length restriction, we used the bit.ly shortening service to keep the target URL short enough. This actually had a bonus that it actually kept track of people scanning the code via the bit.ly dashboard. It had been planned from the start to involve external partners with this project. And after the initial prototyping exercises using our own internal resources, we'd gained enough confidence to proceed and involve third parties. So the original plan had envisaged 3 partners, one for each of the design, the build and deploy phases. The design brief included several elements, having the City of London as a focus point as part of it, also having the crests of the modern livery companies as a graphical element. And we also wanted something to reflect the ethos of modern livery companies and make the AR experience engaging through animation. So the build phase is to take the sort of creative content and create the 3D objects need to be used in the scenes. And then the deploy phase was to take those 3D models and to implement the augmented reality experience on a platform that would be reliable and scalable. In the end, we actually ended up partnering with just 2 companies who provided their expertise free of charge, who were Edge Pictures for the design phase, the Edge Picture company, and AR UVR, who provided the build and deploy functions. So this was made possible by simplifying the design to have the virtual float, the virtual balloon, being a simple geometric sphere rather than a complex 3D object. And then with the output of the creative design phase, simplifying that into an animation, which could then be mapped onto the surface of the sphere with a looped playback when it was rendered. So this slide shows the animation created by Edge Pictures that was mapped onto the virtual balloon surface, which includes all of the design brief elements. So you have these zooming into London, you have the crest of the modern livery companies, and followed then by a slogan, modern livery, rooted in tradition, inspiring the future. So this would be what was used to be projected onto the sphere. So the final piece that we had to do, so in the prototyping process, we used the QR anchoring technique, we're using the QR code itself. This had some technical issues and lots of technical details. Long story short, we couldn't then use the original idea. So we simplified the design, another simplification, and decided to use the internal gyroscope of the phones. So rather than the user experience having to involve scanning and then trying to lock on to another QR code, they just to scan once and then to launch. So what was the outcome of all of the experiments, prototypings, meetings, discussions, testing? So this slide summarizes the final version of the user journey as implemented for the Lord Mayor show. So it starts with the QR code. As you can see, we have on the left, we've got somebody carrying one of the QR code placards. We also created some business cards as well, which were handed out by people walking to spectate in the show. So they could then take them away, scan them later, or scan them if they'd missed the placards going by. So it starts with the process with this QR code. You have the phone, which is then used to scan it. It recognizes the QR code, decodes the URL, which takes us to the bit.ly site. That goes through to the actual AR UVR production site. That loads the screen that you see there, the yellow screen, and you press the play button, which then loads and renders this virtual balloon above procession.
So here's the production bit, as in how do you create an augmented reality float with a Lord Mayor show in 4 months with pretty much no budget? As Stuart has said, we didn't really know what we were doing, and therefore actually making it up as we went along was quite helpful. So with the 4 months that we had, our usual stages of software creation were kind of concatenated, and it went quite quickly. As Stuart has pointed out, our discovery phase in terms of research was pretty much done on the fly with a lot of tryouts in his back garden. And that also kind of meant that the design phase itself was really at the same time with all of the developments that Stuart was looking at. In the background, we were also trying to get buy-in from the modern livery companies in order about trying to work out exactly how we were going to present this QR code to the spectators at the show, and also with an unknown of a random group of people walking along with placards, and also how to distribute the business cards with the QR codes on them. The other aspects to it was that we obviously wanted the new Lord Mayor, who was Michael Manelli in 2023, to fully experience the AR float. And due to some good luck, we actually managed to connect very carefully with him and ultimately get the QR code installed on a iPad so that he was able to have his own version of the AR float as he watched the procession from Mansion House. We were very excited by that. So also with all of the input with AR UVR and the Edge Picture Company, as Stuart has taken you through, we finally had a working prototype. Then, however, we did need to test it. This was quite an interesting situation because, as you can see, with no money, how do you get a focus group together? Well, you wait for a drinks at your livery company, which is called First Thursday, and then you make everyone go down to the street below and test out the AR code, the QR code, complete with their phones before they're allowed another drink. It was quite effective, and part of our testing was to ensure that we decided success was if one person saw the float from that QR code, then we could definitely go ahead. This is our no-go point. The other thing that really helped us was that amazingly we managed to also contact the BBC, who came along for another of our test runs at our livery hall. We're really excited by the technology that they saw and the world's first AR float. We haven't heard of another one, so we're definitely saying it's the world's first. And as a result, featured quite heavily on their cover of the Lord Mayor's show, as we will show you. And so here we are on the day where the show must go on. And this is some of the modern livery companies, including the information technologists, outside our hall, ready to go with some very, very interesting placards with both their arms and also, obviously, the all-important QR code. So here we are on the day itself, and once the procession has started.
Yeah, and not being needed to actually hold the placards, I was running around trying to get to Mansion House in time for the WCIT and the modern liveries to go past. I was also monitoring in real time on my phone the Bitly statistics, so we were trying to keep score. I was also using it to check on the iPlayer, the BBC live coverage, because the BBC covers this. It's a live broadcast and then recorded the highlights later. So I was keeping an eye on the broadcast as well to make sure that we could actually get that Michael managed to get the QR code to work stuff.
And here is the Lord Mayor, Michael Manelli, with his iPad, enjoying the show. We certainly decided that it was a resounding success, and especially in terms of the coverage that we got from the BBC, and the Lord Mayor himself was also delighted by watching the world's first augmented float. And it was a great, absolutely delightful project to work on. Michael Manelli also acknowledged the float and the WCIT master at the Lord Mayor's briefing to delivery after the show. And we certainly couldn't have done it without his support for that from Edge Picture Company and AI and obviously the modern livery companies and the Worshipful Company of Information Technologists.
and a host of people behind the scenes who helped.
So we've got a very exciting procession lined up. What are you particularly looking forward to seeing, Mike?
I love Macy's Day Parade, and Macy's Day Parade is famous for huge balloons. So the Worshipful Company of Information Technologists have created an AR app, an augmented reality, where you can hold the phone at the float that's going by and you can see above it the balloon. And I just love that.
Well, I think, Michael, you and I are both really looking forward to the show.
So looking forward to this, and I'm really excited.
There we can see a first for the Lord Mayor's show, an augmented reality balloon, which spectators can view on their phones after scanning a QR code. And there's the Lord Mayor having a go. And it's worked.
Well, one would hope so. The Lord Mayor is a scientist.
So thank you for your attention, for bearing with us. If you want to find out any more about some of the organisations and events that we were talking about, there's some links on the screen there. And both Danielle and myself will be available now to answer questions through the chat mechanism.